Hello, stat students. I wanted to go over number 4 with you, which was a pretty tricky question. And then we have some new material, but it's not difficult. I hope you won't think it's difficult. So there's number 4 from yesterday. Suppose you're performing a hypothesis test with a null hypothesis of 60%, an alternate of greater than 60%. You're going to sample 100 people and plan to use a significance level of 5%. So we're going to compute the power of the test. But before we go into that, we need to think about what p hat would you need to observe in order to reject the null hypothesis. The power of your test is the probability of rejecting the null hypothesis when you should. And in both A and B, you should reject the null hypothesis. The null hypothesis is false and the alternate is true. But in order to figure that out, we're going to need to know what p hat you need to observe in order to reject the null hypothesis. So we're going to work that out. We know our sample size is going to be 100. We're going to use a significance level of 5%. And by null hypothesis, we expect 60% of our sample to say yes to whatever question we're asking. So with a significance level of 5%, so there's 5%, I can use the inverse norm to work out the necessary z-score. And my observed p hat will have to have a z-score of 1.645 or higher. That will give me a p-value of 5% or less, because then I will be, the shaded region will be 5%, or if the z is even higher, will be even less. And remember, that was my significance level, 5%. So if I get a z-score out here, I will reject the null hypothesis. So I just need to work backwards. So I know the z-score, what p hat, what observed p hat, sample proportion, would we need to see? So there's the z-score formula. So I plug in all the numbers I know. I know mu p hat is 0.60. Sigma p hat, well, that's this formula. Quite familiar by now. That works out to be 0.049. When I solve this for p hat, I get 0.681. So this tells me that I'm going to reject the null hypothesis if my observed p hat that I actually see from my sample is 0.681 or higher, because then it will be out in this region, and the area shaded to the right will be less than 5%. Be less than my significance level. I will reject the null hypothesis. So now the question is, in part A, how likely is that to happen? The null hypothesis is false and the alternate is true in part A. 0.62 is actually greater than the null hypothesis value. So we should reject. And remember, a type 2 error and the power of the test are all conditional upon the alternate being true. Here the alternate is true. It's 0.62. P is 0.62, which is greater than 0.60. So what's the probability in this situation that we reject the null hypothesis? Because that probability, by definition, is the power of the test. How likely are we to reject this false null? So, in actuality, 62% of samples will say yes to whatever question we're asking. Standard deviation, this formula again, works out to be pretty much the same, 0.0485. So we want to know, remember over here, we're going to reject the null if we get a p hat of more than 0.681. So now we need to figure out what's the probability of that actually happening based on reality. This is the actual thing. And so we need to know the z-score for this. We need a z-score for 0.681. Okay, z-score formula, 0.681 minus null hypothesis, or actual mean, 0.62. There's what we're trying to find. There's the mean. There's the standard deviation. That works out to 0.1257. So I need to get this area. Z-score 1.257 is around there. I need to know this area. I do a norm CDF calculation on my calculator, and I get 10.4%. So that's fairly low. This test has low power. We are not likely to reject this null hypothesis. I mean, we'd like to. Our alternate hypothesis is p is greater than 50. P is greater than 0.60, and it is. It's 0.62. But our likelihood of doing so is very small. It's only 10.4%. And the reason this test has such low power is because while the alternate is true, it's not, in a sense, very true. The actual P is just a little bit higher than the null hypothesis P. And so with the sample as small as we're drawing, we're only going to sample 100 people. It's hard to detect a small difference like that between the null value and the actual value. So this test has low power. And remember, a type 2 error would be that if we fail to reject here, so the probability of type 2 error that we fail to accept the true alternate hypothesis here is fairly high. That's around 90%. What is it, like 89.6%? So the situation changes dramatically if the actual value for P is 0.72. Now the actual value is much higher than the null hypothesis. And you'll see here that this large difference between the actual value and the null hypothesis situation is much easier to detect even with a sample this small. So we're going to run through the calculations again, and it'll be a little bit faster. In actuality, 72% of our samples, 72% of each sample will say yes to whatever question we're answering. Not every sample will. There's some variation. And I want to know again what's the probability that we'll get a p-hat greater than 0.681. So I need the z-score. I run through my z-score calculation. I get a z-score of negative 0.869. It's actually to the left of the mean. So my power is now that area. Much, much, much larger. Norm CDF tells me that's 80.8%. So now the test has high power. Remember, power is the likelihood that we reject the null and accept a true alternate hypothesis here. And this is a very powerful test now because the actual value is much different than the null hypothesis. So we see that the power of a test depends on your sample size, because that's coming into the standard deviation, but it also depends on the difference between the actual value and the null hypothesis value over here. So I don't have space, and I don't want to take up the time to do part C. Just to sketch what happens if you change your significance level to 1% is you have to come back over here to this step and change this area to 1%, which would give you a new Z, and that would give you a new p-hat cutoff to reject. Then you come back over to the situation, and you would use this the new p-hat here in these calculations. I worked it out. Power is 55.3%. So if you did it, you can check your answer. Or if you worked through it, you can see whether you got it. You can check against that. So that was that nasty number 4 from last night. Let's move on. New stuff won't take very long. It'll be done in just a few minutes here. So I want to talk about testing using confidence intervals. You can use a confidence interval that you've computed to decide whether to reject a hypothesis. Let's say your alternate hypothesis is a greater than, and then you have some confidence interval. You're going to reject this You're going to reject the null hypothesis and accept this alternate if the entire interval is greater than whatever your null hypothesis value is. So if you said 40% here and your whole interval was over 40%, you would reject your null and you would accept this alternate hypothesis. Hopefully that makes sense. You're checking this. You're trying to prove that P is greater than some value. You have a confidence interval, and the whole interval is greater than that value. Well, yes, then we would reject the null and accept that alternate. And of course, if the alternate were less than, then this statement is the same except it's less than. Now you want your entire interval to be below whatever your null hypothesis value is. And if your alternate hypothesis is not equal, then you're just going to reject if the interval simply doesn't contain the null hypothesis value, if it just misses it. So a quick example. Let's say you have an alternate hypothesis of P less than 0.25%. Then you have a confidence interval that you've computed, and it's 0.186 to 0.261. There's my confidence interval. Would I be able to reject my null and accept this alternate based on this confidence interval? You know the answer? Hopefully you do. Is this interval entirely below 0.25? The answer is no. 0.25 is actually in this interval. 0.26. The top end of the interval is 0.261. So in this case, we would fail to reject. We couldn't conclude what we wanted to conclude, our alternate hypothesis, because the confidence interval was not in its entirety below 0.25. According to this confidence interval, the null hypothesis value of 0.25 is still plausible. So, last thing. I want to talk about the relationship between confidence intervals and significance levels of tests. So, another example. Let's say now we have an alternate of p greater than 0.60. And we compute a 95% confidence interval and we get this, 0.616 to 0.697. So what about now? Could we reject our null and conclude this alternate right here? You know the answer this time? I hope so. The answer is yes. The entire interval is greater than our null hypothesis value of 0.60. So in this case, we would reject the null hypothesis. And we can conclude that our value is actually greater than 0.60. So the question is, what significance level are we using when we do this? What's the significance of this test? After a while, we didn't have an alpha and get a p-value and do all that, so I just want to talk about what's the relationship between this confidence interval and the significance level of the test when you use a confidence interval to perform a test. So significance level, remember, is alpha. That's the probability of the type 1 error. That's the probability that you reject the null hypothesis when you shouldn't have, when the null hypothesis was actually true. So let's think about our confidence interval. We've just computed a 95% confidence interval here. So it's at 95%. And the endpoints of the interval are 0.616 to 0.697. There to there. So when could we have screwed up? We rejected the null hypothesis. When could we have screwed up? Could we have, I mean, obviously, if 0.60 is in here, or if the actual value is in here. Remember, we don't know where the actual value is exactly. It's fixed somewhere, but it's where it's fixed, we don't know. So if the actual value of p is in here, we're good. We're trying to conclude that p is greater than 0.60. And if it's in our confidence interval, we're good. So we're still good if it's out here. Our confidence interval would have missed the actual value, but it's still greater than 0.60. The issue is if the actual value is under 0.60, which is only possible if it fell into this tail over here. Now, we know what the area of that tail is. That's the whole area is 95%. Each of these tails is 2.5%, therefore. Each is half of the remaining 5%. So if our actual p is down here, we could have rejected an error. And we reach a conclusion, reject. But if our actual p landed in this tail, which is 2.5% of the area, we made a mistake. And the probability that it would be in that tail is roughly 2.5%. So that's the significance level of this test. When we use a 95% confidence interval, here we end up with a significance level of 2.5%. What I'm saying here is using a 95% confidence interval to perform this test is equivalent to using an alpha of 2.5%. That's what I'm saying. So that's your alpha when you use a 95% confidence interval. So, in conclusion, for a one-tailed test, if you use a confidence interval to perform the test, the alpha level, the significance level of that test, is 1 minus the confidence level divided by 2. It's the area in one of these tails. So if you had 90% confidence, then the significance would be 5%. It would be the same as using alpha 5%. If you're doing a two-tailed test, with your alternate hypothesis being not equal to, then you screwed up and made a mistake if you reject if the actual value is in either tail. So we lose the divided by 2 here. Two-tailed test, when you use a confidence interval to do a two-tailed test, the alpha level of the test is just 1 minus the confidence level. And that's all for today. You have another short homework assignment, and then Tomorrow, you'll have a large practice quiz, which will have a lot of different ideas. I'm going to be wanting you to know we've done 2 chapters while I've been gone. We've done chapters 20 and 21. We actually started 20 while I was there. And then on Monday, we will we'll go over that practice quiz in class. And then on Tuesday, we're going to take a long quiz on those 2 chapters. So have a good day. I'll see you soon. Bye-bye.